Hello, my beautiful computer science students. Welcome to another lesson where I take you through arithmetic expressions. We are still in Unit 1 talking about primitive types, but now we are on Lesson 4 where we're going to go over how Java handles different mathematical expressions in the code. So let's go ahead and get started. So first we got to talk about Java's order of operations, or as it's known in the coding world, order precedence. Okay, so how they evaluate expressions when you have a lot of symbols mixed in. Luckily, it's a very familiar flow. So first starts with parentheses. Java will do any parentheses, any operation inside parentheses first. I should make a note that Java does not recognize parentheses itself as an operation. So usually, like you could do, in math class, like if you had this 3 parentheses 4, you knew that as multiplication. Java does not recognize that as an actual operation itself. That would be an error. Okay, so in order to use multiplication, you actually have to use the asterisk. Okay, and so the asterisk represents multiplication, and the slash is going to represent division. Okay, so first parentheses. So any operation inside parentheses gets evaluated first. Okay, and then after parentheses, after all the operations inside parentheses are taken care of, next is multiplication and division from left to right. Okay, so if you have multiple operations with multiplication and division, it's always from left to right evaluated. And then the last one is addition and subtraction, left to right. And if you're familiar with the order of operations, you know that that looks good, except for the exponents. Okay, now there is no built-in exponent symbol. You might be tempted to use that caret symbol, but Java does not recognize that as an arithmetic operation. There is a way to handle exponents that we're going to learn about in Unit 2, but for now there is no built-in symbol that represents an exponent. Okay, there are just parentheses, and that tells us what operation to do first. Multiplication, division, addition, subtraction. Okay, let's get into some basics here. So for all of these next pieces of code, I just have a print line statement to print out what the answer is to each of these expressions. So here we have 3 plus 4 times 2. So the two operations we have are the plus and the multiplication, and with order precedence, you know that the multiplication happens first. Okay, so that's going to happen. 4 times 2 is evaluated to be 8, and then the addition happens. 3 plus 8 is going to give you 11. Okay, and that's actually exactly how you would have solved a math problem as well. So hopefully that's not anything too shocking. Okay. And Java can be shocking. We'll figure that out. Okay, here we have 3 operations. We have the plus, we have the division, and we have the multiplication. So we know order precedence, multiplication and division happen, but from left to right. And the first thing you encounter from left to right is the division. So that's going to happen first. 5 divided by 5 happens to be 1. Okay, and then we're left with 2 plus 1 times 2. So between the plus and the multiplication happens next. Okay. 1 times 2 is 2. So then you're just left with the addition, which is going to be 4. Okay. So I want you to notice here how this code, the expression was on the right, and then our answer 4, once the expression was evaluated, 4 got stored in the container answer. Okay, so 4 got stored in answer, and then the print statement printed off what was stored inside answer. Okay, so we used an intermediate variable to evaluate that expression. Okay, next up we have 3 variables now. Okay, so x is 9, y is 2, and then z is going to be the expression y plus x times x. Okay. When you start having multiple variables and you have to keep track of their values, one thing that I recommend is a trace table. Okay. Okay. Now, a trace table, I know a couple things just popped up on the screen, but look at the trace table right underneath the code. So I have headers for X, Y, and Z. So X, I put a 9 underneath. Underneath Y, I put a 2. And underneath Z, I put my expression with those variables plugged in. So since Y right now is currently 2, I plugged in 2 plus 9 times 9. And then Java will evaluate that expression before it stores it in the variable Z. So 2 plus 9 times 9, the 9 times 9 gets evaluated first. That's going to be 81. And then it's going to be 2 plus 81 to give us 83. Okay. So 83 is now stored in Z. And so when you go to print and you print off the value of Z, you're going to print off an 83. Okay, here's a good one. So 9 divided by 2, right? Right away, I know you want to say 4.5, right? If we typed in 9 divided by 2 on our calculator right now, 4.5 would be our answer. Okay. However, this is where Java gets really fun, okay? 9 and 2 are both integers. So Java performs something called integer division, right? It handles division between integers and doubles differently. So between two integers, it performs integer division, which means how many times does the 2 fit evenly into 9? Okay, so when we had our 4.5 here, okay, the 2 went into 9 4 times, okay, right? 2, 4, 6, 8, 4 times. And then there was a leftover piece, okay? There's 1 left over, and then 1 divided by 2 is 0.5. Okay, so that's how you get 4.5. If you kind of remember your math from elementary school, way back when, okay? But it goes in evenly 4 times. And in integer division, Java reports only the 4. Okay, so when you print off this statement, you're only going to get a 4. Okay, that's just one of a very long series of fun things that happen with Java. Okay, here's another example. Okay, because after I show that, usually the next question students pose is, okay, let's store it in a double then, right? So here I have X is 9, Y is 2, and then I have a double Z. So that I take this expression here, 9 divided by 2, and I take that result and I store it in Z, okay? And again, you're very tempted to say, oh, 9 divided by 2 is 4.5 and it's stored in a double, which can handle a decimal. But that is not how Java evaluates that, okay? When Java evaluates an expression, it's only looking at the X and Y when it evaluates that expression. So since those are both integers, the expression is still evaluated as integer division. So 9 divided by 2 is still going to be 4, because those are both integers. The 4 gets stored in a double, and you know when we have an integer stored as a double, that's allowed, that's totally fine because an integer is smaller than a double. So you can store that 4 inside the Z. When you go to print it off though, because it's a double, it prints off as 4.0, okay, which is very counterintuitive to how you've been handling division up in math until this point, okay? So be careful of that. Java does integer division when it's between two integers. Okay. What if it's not? Okay. What if it's not? What if you have mixed expressions? Because so far, all of the examples we just saw were between integers, right? Addition, multiplication, division, all of that was between integers. What if you have operations between doubles and integers, or even like shorts and integers, which again we don't cover in AP CSA, but they still exist. The most you'll encounter in AP CSA is going to be doubles and ints. So that's where I'm going to kind of focus on the mixed expressions piece. So a mixed expression has the operands like the plus, minus, divide, multiplication with different data types between like doubles and ints. Remember that doubles hold larger spaces in memory than int values. So a double is in Java what's considered more complex because it is larger. Okay, so I have that visual from a previous lesson to remind you. Double is considered more complex because it's bigger. When there's a mixed expression, Java will temporarily promote the less complex type so that it matches the more complex type, and then the operand is applied. Okay, the operator is applied. Okay, so that means if between an integer and a double, right, an integer is smaller than a double, trying to do a visual here. Integer is smaller than a double. So if you have a mixed expression between the two, Java will promote this integer to a double, perform the operation, and then the result, because it promotes it, and the operation occurs between two doubles, that means that your result is going to be a double. Okay, with me here? I have plenty of examples to follow along here. And here we have our 4 examples off to the left here, and then the reason why the console is going to print off what it prints off. So you see the first line, focus on the first line here, 10 divided by 4. Well, we went over that. That's integer division. The result is going to be an integer, right? 4 goes into 10 evenly twice, okay? And then there's 2 left over, right? 4 goes into 10, 4, 8, and then 9, 10. There's 2 left over, okay? So 2, it goes in evenly. The next line, you see we have 10.0 divided by 4.0. So Java reads that as division between 2 doubles, and the result will be a double. Okay. When the result is a double, that means that the division is performed as you would expect. Right? If you take 10 divided by 4 on your calculator, you would expect to get 2.5. Sorry. You would expect to get 2.5, right? And because the result is a double, that's exactly what you're going to get printed to the console, because it's division between 2 doubles. Okay. Now, the next line, you see we have the mixed expression. 10 is an integer divided by 4.0. Okay, so integer divided by a double. This mixed expression here, and I have the reason over here, Java will temporarily promote the 10 into a double. Okay, and then perform the division between the 2 double values. And the result is a double value as well, 2.5. Okay. Now this last line, I want to show you on here, and then I'll run it in Replit so you can actually see that I'm not lying to you. But this kind of demonstrates how Java is temporarily promoting the less complex type. Okay. So we have an int a equals 10. We have a double b equals 4.0. And then c is going to be a divided by b. Okay. So a is an integer divided by a double b. And we just saw when we have the mixed expression, our result is going to be a double. Okay. So this is still going to be 2.5. And c, our variable c is a double. Perfect, because my result is a double, I have to store it in a double. So when you go to print off c right here, you're going to see 2.5 print off. Perfect. And then when you go back to print off a, okay, a never changed values. It was temporarily promoted to evaluate the expression, but it never actually changed values. So when you print off that a, you're still going to get 10. You are not going to get 10.0. Okay. And I'm going to switch over to my Replit screen if I can find my mouse. There we go. And I'm going to run that code just to show you that, okay, int a, here's the exact same code, cb, print off ca. When we run that code, we get our 2.5 and our 10. When it runs, if she's being a little testy this morning. There we go, 2.5 and a 10. Okay, so Java temporarily promotes that 10 into that mixed expression. Okay. All right. We got a couple more here. Now we're going to be mixing, or excuse me, we have one more mixed expression, but then we're going to start mixing some string literals here. So for this one, 1.0 times 3 divided by 4. Okay. So multiplication, division, what happens first? It all depends on what's there left to right. Okay. So left to right, the 1.0 times the 3 happens first, and that's a mixed expression. 1.0 times 3, the 3 gets promoted, so that 1.0 times 3.0, the result is just 3.0. Okay. And then you have 3.0 divided by 4, another mixed expression, and the 4 is again promoted to a 4.0. 3.0 divided by 4.0, that's double division. So that happens like a calculator. Double division happens like a calculator. 3.0 divided by 4.0, that's going to be 0.75. And that's what's going to get printed to the council. Good stuff. Okay. Now, mixing strings, we've kind of talked about this a little bit in the past notes, but let's just go over a couple of different things here. When you have a string literal, so you have the 3 plus 4 inside quotation marks here, what gets printed is the actual string literal. Okay? Java does not evaluate expressions inside a string literal. Okay? When you have a string mixed with an int, or even a string mixed with a double, the string is the most complex type. So if you mix the two, whatever number you have will get promoted to a string. So it reads that plus as concatenation because it promotes the 4 into a string. So 3 plus 4, 3 and 4 get pushed together into 34. Okay, I got 2 more left here. So this, again, the 3 plus 4 plus 5, right? So Java sees this 3 first and says, okay, we're working with strings, which means that when it runs into the 4 next, it's going to promote the 4 into a string. So the 3 and the 4 get pushed together like a string, like we saw in the last one. And then it'll see the 5, promote that as a string, and push that together. Okay? So all of those pluses get read as concatenation symbols. Okay? So you get 3, 4, 5 when you have it like that. Now let's say you actually wanted the 4 and the 5 evaluated first. That's where parentheses comes in. So you see you have your string here plus, but then you have parentheses around the 4 and the 5. Java goes to the 4 and the 5 first because they're inside their own set of parentheses and evaluates that plus. And since the plus is between the 4 and the 5, it does integer addition. So 4 plus 5 is 9. And then Java will do string plus integer. So string plus integer gets pushed together to concatenate into 39. It's a lot of good stuff. There's a lot of examples there. If you wanted to go to your own IDE and try a couple different things to see what would happen, you can always play around with it, right? And see, how does Java do this? How does Java evaluate this expression? And it'll help you practice a little bit more too. Okay, let's move on to the next type of thing you have to look out for when you're doing arithmetic expressions. And that's going to be division by 0. Okay, don't divide by 0, right? We don't allow it in math class. We don't allow it on Java. It will protest largely. But the thing is, it'll compile fine. But when you go to run it, that's when your program will crash. You'll encounter a runtime error, and this arithmetic exception is going to be thrown, meaning that the code basically throws this error to your screen and says you tried to do this, which wasn't allowed. Okay, so here's an example. This code compiles fine. This is correct code that I have written. Syntax-wise, it's going to compile perfectly, but it's going to crash when it runs because you're taking 5 divided by 0. And it just doesn't allow that. What that's going to look like, you're going to see that exception, right? So when you go to run your code in the console, you'll see exception, arithmetic exception, and it'll actually tell you tried to divide by 0 on line whatever it was. So careful of that. Don't divide by 0. It can't work. Okay. The next thing, compound operators. So there's a running joke that computer scientists are lazy. Okay? And that whenever we can find a way to shorten code, we want to shorten it. And that's where compound operators come in. Compound operators are helpful when you just want some short, concise code. So in this table, I have what a regular operation would be, and then we have a special shorthand compound type. Now, you don't have to use the compound operation. Like, there's no requirement. But as a programmer, you want to be able to see it and understand what it means. Okay? So let's say the regular operation, you have the variable x, and you want to take that value and add 5 to it. Right? So I have my container x. Whatever value is in here, I want to add 5 to it. And the regular operation, that's what that would look like. The compound operation looks like this. Okay? So it says take the value of x, add 5 to it, and then store it back in x. Okay? My little trace. That's how I kind of think about it when I read it. So you may or may not be the same way. But that's a compound operator. So when you see the plus equals, okay, that plus equals means take the value that's in x, in this container, and add 5 to it, and then just keep it in x. And we have these compound operators for each type. If we try to take x and subtract a value, whatever value, it would be minus equals. If we try to take this value times anything, in this example it's 5, we have times equals. Maybe you see where this is going. Divides equals. Ooh, we haven't talked about this yet. We're going to in a couple minutes. This is the mod operator. We'll talk about it momentarily, but we can also have a compound operation for it. And then these last two. These are special cases where if we want to take the value of x and add 1 or subtract 1. So specifically adding 1 or subtracting 1. These other compound operations you can do with any number over here. Okay, it doesn't have to be these numbers. You can do it with any number. But specifically these last two, this is when you want to add 1 or subtract 1. These compound operators, to add 1, you do x plus plus, or to subtract 1, you do x minus minus. Okay. And those are specifically adding 1 to x or subtracting 1 from x. Okay. And x is just a variable. You can use any identifier for that. Okay. So I have 3 short practice problems. Just kind of thinking about how these look in code. If you want to pause the video and try them on your own, and then press play when you're ready to go over the answers, I highly recommend practicing first on your own, but I'll go over the answers when you're ready. So for this first one, int x equals 10, and then we have x plus equals 5. So 10 is stored in x, and when I see that compound operator, that means take 10, add 5, and then keep that locked up in the variable x. So that's going to be 15. Okay. So hopefully that's pretty straightforward. It's really just getting used to the code and how it's written, which can be a little wonky if you've never seen it before. So y has 17. We're going to take 17, we're going to subtract 4, and we're going to keep it locked in y. That's going to be 13. And then the last operator, we have 9 stored in z. 9 times 5 is 45, and that's going to get stored back in z. So again, just kind of getting used to what those look like. All right, so those are compound operators. Let's talk a little bit more about those last two. They're called unary operators, so the plus plus and the minus minus. So the way I wrote it, x plus plus and x minus minus, that's usually how we're going to write it in our code. Okay? That's called a post increment and a post decrement. We also have unary operators where we have pre-increment or pre-decrement. And here's my 4 examples. So the pre-increment, let's start on the left here in the notes. Int g equals 5, and I have plus plus g, meaning take the value of g and add 1 to it. It's going to be 6. Okay. Here's another example. I equals 5, 5 plus plus. You get 6. Okay. The pre-increment and post-increment actually work the same way when the code is written like this. Same thing with the pre-decrement. Minus minus h means you take 0 and subtract 1, so you'll get a negative 1. And then post-decrement, same thing. P minus minus, you take 0, subtract 1, you get negative 1. Okay. For the code above, it does not matter if you use pre or post. Okay. Okay. Most of the time, you'll see code written with the post. It's just habit, I guess. There'll be occasionally you can write it with the pre, okay, but most of the time you'll see it with the post. That's just how it is. The only time it matters, okay, is when they are in parameters, okay, in a method. And we haven't talked about parameters and we haven't talked about methods yet. So you might be a little lost there. The only one we have talked about, and I'll show you an example of, is the print line method. Okay. Now, before I go through this example, just know that we're getting kind of picky here. And the computer science exam doesn't specifically test over this type of pickiness, okay, because it is pretty picky. But I just want to make sure I explain it thoroughly, the Unary operators thoroughly. So just know that while this does seem really picky, this is just how the code works. And if you were ever writing a program and you encountered something like this and it feels like it's kind of wonky, this is the reason why it's wonky. Okay. All right, so let's do double example equals 4.5. So we have a double. Now we can add 1 or subtract 1 from a double. That's no problem. Okay. So this first one, I have system.out.println plus plus example. Now the pre-increment here says that you are going to take example, you're going to add 1 to it, and then you're going to print. Okay, that's what a pre does, right? A pre-increment says, okay, before you do anything, increment it. Okay, so it's kind of what you would expect. The output ends up being 5.5. You take 4.5, you add 1, and then that's your output. The post increment does something a little that you wouldn't expect. Post increment means do it after, right? Post means after. So what this print line statement will do, it'll take example, it'll print it, and then it'll add 1 to it. So right now, example is 5.5, okay? Because this, I should also make a note here, means take example. Remember that this meant example equals example plus 1. Okay, so when we use the Unary operators, we are actually changing the value of the variable. Okay, we are not just changing it temporarily. If we were to change it temporarily, okay, if we had system.out.print example plus 1, and we just had example plus 1, it would output a 5.5, but in my container, I would still have a 4.5, okay? Expressions don't change your variables unless there's an assignment operator involved. And when we have our Unary operators or compound operators, right, we have an assignment involved, okay? So the actual value of our variable gets changed, okay? So I hope that's clear. You play around with it in your IDE if you want to trace that a little bit more. So right now, when I did plus plus example, 1 got added to example and then stored back into example. So the actual container value got changed. So it's 5.5. When I move on to the next line, example plus plus, it's a post increment, meaning that I'm going to print off 5.5 and then I'm going to change example and add 1. So this next line, the output is actually still 5.5. Okay, example, and I'll try not to shake my screen as I write, is 6.5. Okay, but because it was a post increment, it prints off example and then it increments behind the scenes. So in the last step, when I print off just what example is, my output is 6.5. Okay. Like I said, we're getting pretty picky now, okay? And I haven't seen the AP exam be this picky, okay? It has not been this picky, but I want to just make sure I'm doing a good job, again, going through some of this, okay? So if it's still not clear, practice it a little bit in your IDE, try a few different things, and we'll get used to it. It'll be okay. All right. We're almost there. One of the last things we're going to talk about is that modular division, that percent sign we saw in our compound operator. Let's talk about what modular division is. So we talked about integer division, how when we take, 7 divided by 2, it's how many times does 2 go into 7 evenly. Okay? In math class, when we take 7 divided by 2, we get 3.5, and we would expect that to be the answer. I want you to think back to when you first learned about division. Back 3rd, 4th grade, whenever that was. When we started doing division back then, you weren't working with decimals. You were working with remainders, right? So if you had 7 divided by 2 back in 3rd grade, that was equal to 3 remainder 1. Okay? 2 goes into 7 3 times evenly with 1 as a remainder. Okay? Integer division is interested in the 3, right? 7 divided by 2, integer division is a 3. Okay? Modular division says 7 divided by 2 is going to be 1 because modular division is interested in that remainder. Okay? Modular division is finding that remainder basically after integer division is performed. Okay? The remainder operator, or the modulus operator, is the percent sign. Okay. So it's a new operation, and it has the same order precedence as multiplication and division. So again, if you have a mixed expression with many operators, division, multiplication, and the percent sign, the mod operator, all of those are on the same level. So all the mod operators would get evaluated before addition and subtraction. Okay. So if you've seen mod division before, you already know what it's about. You're okay. If you haven't seen it before, you just got to practice it a little bit. On the AP exam, they don't get crazy with numbers. Okay, they keep the numbers pretty low if they do want you to figure out the mod operator. There are ways that the mod operator is actually useful in a program, and we use it for more than just evaluating expressions. So we'll talk about that in a moment. But let's practice just strictly evaluating them. Okay. So this first one, 10 mod 6. So that's how we would read that expression, is 10 mod 6. Let me kind of do the long visual way first for you. So 10 mod 6 means that you're taking 6 and dividing it into 10 and seeing what your remainder is, right? So think, again, I kind of wrote it like you did back in like 3rd and 4th grade, right? 6 goes into 10 once, okay? 6 times 1 is 6. We subtract these, we get 4. 6 doesn't go into 4, so my answer, 1 remainder 4. Okay. Now the mod operator is strictly concerned with what that remainder is. So when you take 10 mod 6, the answer is going to be 4. Okay. So again, that goes from that. That's kind of the long way of doing it. You don't have to show that work every time, you're doing scratch work. But just visually, if you kind of like that while you're getting used to it, it's a good way to get used to it. 39 mod 6. So to do this, you could do the long integer division. What I personally like to do is I like to think, okay, 6. What's the largest number that I can get 6 to divide evenly into before I go over 39? So I think of 36, right? 6 goes into 36 evenly, and I'm still under 39. Well, what's the difference between 36 and 39? That's going to be a 3. And that's the remainder, that's the leftover piece. So that's how I personally like to think about it. 12 mod 4. Okay. 4 goes into 12 actually evenly, right? 4, 8, 12 goes in evenly. So the remainder for that one is going to be 0. Okay. So a remainder of 0, it goes in evenly. 17 mod 2, I know that 2 goes into 16 evenly, and there's going to be 1 left over after that. And then we get into the zeros, okay? So 1 is actually a divide by 0, which is an error, and the other one is just 0, right? So remember how, right, this would be 0, and this would be undefined, or a divide by 0 situation. So which is which in this situation? Okay, 0 mod 5 means that you see how many times 5 goes into 0. Okay, that's this option right here. Okay, so 0 mod 5 or 0 mod anything is just going to be a 0. The other way, okay, is going to be a divide by 0 situation, and that's going to throw an arithmetic exception. Okay, so we're not going to get into like crazy numbers on the AP exam. Maybe in your program if you really want to use it for certain reasons, but usually we don't get into crazy numbers. There's a couple of different ways to use the mod operator. One of the most common ways. Okay. Ooh, actually, before I get to that, I forgot I put this little note in here. These mod operators were just on integers, positive integers. And that's really what the AP exam is going to stick to, and that's usually what you stick to in your program. You are able to use the mod operator on doubles and negative numbers, but the result is not as intuitive as you would think, actually. So those problems aren't covered on the AP exam. And honestly, I haven't used them in practice either, but you are able to use the mod operator on those values. Okay. But we're going to stick to positive integers. Okay. So sorry, back to using the mod operator. The most common way is trying to decide if a number is even or odd. Maybe the number the user inputted, or whatever number you have, whatever variable you have, and you want to decide if it's even or odd. Making that decision is using the mod operator. Okay? When dividing a number by 2, if the remainder is 0, that number is even, right? So 10 mod 2 is equal to 0. That means that 10 is an even number. On the other side, if the remainder is 1, then that means that the number is, ooh, sorry, this should say odd. That means the number is odd. Okay? So 11 mod 2 is equal to 1. The number is odd. So we'll start seeing that when we get into like making decisions in Unit 3, how we make decisions in a program. Mod operator will come back a lot in that unit. Okay, finally, one last thing. Statements are not relationships. Okay? Once the code is run, it does not go back and run again. Okay? This is a very important idea here. So we're going to trace through this short piece of code here, this example. So I have three variables here. Okay, so I'm going to do a trace because I have 3 variables and I like to trace. I have bill 42. I have a tax percent 0.1, and then I have tax, which is that tax percent times bill. Okay, so bill is 42, tax percent is 0.1, and then tax, the variable tax, I take my tax percent, which is 0.1, times my bill, which is 42.0. 0.1 times 42 is 4.2. So 4.2 gets stored into tax. Okay. Hopefully you're with me so far. This next line, my compound operator, bill minus equals 10. That means take the value of bill and subtract 10 from it. So I get 32, right? Now, be careful. That does not mean that this statement is not a relationship. So when you took out $10 from your bill, your tax does not get recalculated at all. Tax was already calculated. It is done and over. Okay? It does not go back and run that relationship again. Okay? So if I were to print off the total tax right here, okay, total tax and then plus tax, tax is still 44.2. Okay? It does not change because my bill changed. Okay? Statements are not relationships. So make sure that you're not going back and doing that in your code. Once the code is it runs top to bottom. Okay? The statements run top to bottom. As soon as one statement is run and we move on to the next thing, this doesn't go back and run again. Okay? Well, right now it doesn't. Okay. That is it. thank you so much for watching lesson 4 today. We have one last lesson before we get into our next unit. So I will hopefully see you again in lesson 5, and have a great day.